Okay, now we're going to dive into something maybe completely different to you, but you've worked with something like this before. What we're talking about today is partial fractions. So let's talk about what in the world partial fractions are and then why we might need to use them. So in algebra, we may have something that looks like the following: 1 over x minus 1 plus 1 over 2x plus 1. So basically, if you think about it, take yourself back to elementary school for a second. We are adding fractions, and in order to add fractions, we need a common denominator. So in the case of algebra, when you've done this in an algebra class or maybe algebra 2, you needed to find a common denominator, and you usually work with the fact that it's just the product of the two denominators that are there. So we're going to have x minus 1 and 2x plus 1 as the common denominator, right? And what ended up happening was that this side over here got multiplied by 2x plus 1, and this side over here got multiplied by x minus 1. And so what ended up happening over here on the top of your fraction, you had something that looked like this: 2x plus 1 plus an x minus 1. And you do some combining of like terms, and you get something that looks like this: 3x over, and I'm just going to multiply this right here really quickly in my head, and you're going to get 2x squared minus x minus 1. Okay, so these two fractions here work out to be this over here. All right, that's algebra for you. In calculus, and this is assuming, maybe you're watching this in a calculus course, or maybe you are, in a pre-calculus course preparing for calculus, for example. But in calculus, we may need to write something like 3x over 2x squared minus x minus 1 as a sum of simpler fractions. So those simpler fractions would be, well, what we started off with in algebra. So you have to really break it down. And you're breaking it down to what you originally had, which was this stuff over here. So notice the connection, and you'll start to understand, well, this is why we were doing it in algebra class. Okay? And you have a greater appreciation for it, because when you get to calculus, you're going to be doing some advanced stuff called integration. And when you're integrating, sometimes looking at something that looks like this is a lot easier than working with something that looks like this. So that's the whole point of learning about partial fractions. It's really a nice pre-calculus topic. But let's go ahead and dive in and figure out, with a couple of examples, how in the world would we decompose a fraction. Okay, so we're talking about partial fractions, but really the concept here is partial fraction decomposition. And what do we mean by decomposition? Well, we mean we're going from this format to this format here. Okay, so that's what we mean by partial fraction decomposition. So let's take a look. We have something that looks like this, and this is the first case, and there's other cases, and I'll make more videos on that. But the first case is real simple. It is the case of distinct linear factors. And what do we mean by linear factors? We mean stuff that looks like this. Okay, if you were to graph each one in isolation, the graph would be a line. So that's what we mean by distinct linear factors. And distinct because they're not repeated, they're not a double. Okay, they don't have a multiplicity of 2, in other words, or a multiplicity beyond 2, I should say. So we're going to assume that the denominators of each of these two partial fractions are the two denominators that are already present, just like that. Now, the trick is we don't know what goes here, and we don't know what goes here. So we're going to assign to it a variable name. And I'm going to actually call this one A, and I'm going to call this one B. All right? Instead of using X and Y, because we're already using X, use something completely different, A and B. So what we're going to do is we're going to use a method that will get rid of the fractions for us, because we really don't like fractions to begin with. I think that's one of the challenges that everybody faces. So what we're going to do is we're going to, and I'm going to zoom out just a little bit here, just so we can, well, that didn't do too much for me. Okay, so let me just take it back in. I'm going to multiply everything, the numerator and the denominator, by the denominator itself. So I'm going to multiply this by x plus 2 and x minus 5. Okay, but that means that all of this also has to get multiplied by x plus 2 and x minus 5. Okay, because what you do to one side, you have to do to the other. Now what happens here is that this ends up crossing out through division. Some people say cancel, crosses out, lines out. Okay, this leaves you with 4x minus 27. Now over here, when you take these two and you multiply them in, you distribute them in, well, what happens? You have a times x plus 2 times x minus 5, and then divided by x plus 2. So you're left with a times x minus 5. The x plus 2 cancels here and here. Okay, now I'm going to undo that. There we go. So that now I can distribute to the b. So we're going to have plus, okay, and then we're going to write b, and then in this case, which factor cancels? The x minus 5 cancels or crosses out, leaving us with b times x plus 2. So it looks something like that. Now we have kind of what appears to be a very simple system of equations, but it's really just kind of one equation. We're just going to kind of make some wise choices, and I talk about wise choices when I go over this in class. Wise choices for x, because we're going to pick a value for x that will help us solve for these two important values, a and b. Okay, so let's talk about wise choices for x. What would I pick for x, suppose, if I wanted to solve for one of these, a or b? Well, I'm going to pick x equals 5. That is my first wise choice. Now why? So I'm going to, let's say I'm going to call out this x minus 5 here, and I'm going to set it equal to 0. And when I do that, what do I get? I get x equals 5. So this right here will make all of this in this area equal to 0, and I'll be able to actually solve for b. But let's prove that. So I'm going to say 4 times 5 minus 27 equals a times 5 minus 5 plus b times 5 plus 2. All right, so when I work on this, I actually get 4 times 5, which is 20, minus 27. And then the 5 minus 5 is 0, so this actually cancels that out. That really does cancel. And then I get equal to 7b. So then I end up with something that looks like this. Negative 7 equals 7b. Okay. And then, of course, you divide both sides by 7. And you get something that looks like this. b equals negative 1. So we're going to come back to that in a second. We're going to come back to that in just a second. But what we're going to do next, and let me give myself a little more writing room here. Okay. What we're going to do next is we're going to actually now solve for a. So if I'm solving for a, I need to pick another wise choice. Well, let's take a look at this one, for example. X plus 2 equals 0. So x equals negative 2. So a wise choice for x will be, you guessed it, negative 2. So x equal negative 2 is my next wise choice. Negative 2, 4 times negative 2 minus 27 equals a times negative 2 minus 5 plus b times negative 2 plus 2. All right, what happens? First thing we notice is that we have negative 8 minus 27 equals, and then this right here works out to be negative 7a. And then this negative 2 and 2 is 0 times b is just 0. That does cancel out. And we end up with something that looks like, we end up with something that looks like this. Negative 35 equal negative 7a. So then we divide both sides by negative 7. And we get a equals a positive 5. So b equals negative 1, a equals 5, but we're still kind of not done. We have to write out our decomposition. Well, that means we're going to have to go back. So here, right over here, in this region, we had a over x plus 2 plus b over x minus 5, and we're going to write, let's see here, a is 5, so 5 over x plus 2 plus a negative 1 over x minus 5, and this is what our partial fraction decomposition looks like in the case of distinct linear factors. So now might be a good time to pause the video and re-watch it if you didn't quite understand, but otherwise if you're ready to move on, let's take a look at number 2, the next example here. All right, so I've got another case, 13x minus 34 over x squared minus 6x plus 8. This problem, it's just as simple with one extra little step, okay? And that is that you really have to know how to factor. So before we do that, before we break it up, we need to factor this denominator right here. We want the factors of 8, a positive 8, that add to give us negative 6. So let's think about it. Factors of 8. Okay, let's see. 1, 8, 2, 4. Those are the only factors of 8. Which ones add to give me negative 6? Well, 2 and 4 add to give you 6. If they were both negative, then they'd both add to give you negative 6. So I found my distinct factors, x minus 2 and x minus 4. So that's what would happen there. Now that we've got that set up, we're going to have to write it as two partial fractions. So something that looks like this, x minus 2, x minus 4. Okay, so we've got our a and our b, and we're going to do again the same thing. We're going to clear the fraction by multiplying it by x minus 2, x minus 4. Okay, all of it gets multiplied by that. And that right there will take care of our fractions, and we're good. So we're going to end up with something that looks like this, 13x minus 34 equals, now this right here, it's very evident that it cancels out, but let's take a look over here. X minus 2 times x minus 4 times a over x minus 2. The x minus 2's cancel, leaving us with a times x minus 4 plus b times, now in this case the x minus 4 cancels, so leaving us with x minus 2. So that's really nice right there. All right, nothing to it. Now we again talk about wise choices. What can I pick for x so that I can cancel potentially something out and then solve for the other variable? Okay, so I'm looking here, and I think x minus 4 equals 0, so x equals 4 is a good choice, a wise choice I should say, and this one would be x equal a positive 2. So we'll come back to the positive 2, but let's try x equals 4 in the first case. 13 times 4. So wherever you have, remember, wherever you have an x, you're going to plug in 4. All right, so we get rid of the x factor. All right, and we're going to have a times 4 minus 4 plus b times 4 minus 2. Now you should have already noticed that the 4 minus 4 there is going to cancel itself out, and we're going to be set up right now really quickly to solve for b. Okay, so now we do 13 times 4, which is 52 minus 34 equals, and then 4 minus 2 is 2, so equals 2b. To be or not to be, that is the question, right? All right, 52 minus 34 is 18 equals 2b, so we divide both sides by 2, and we get something that looks like this. b equals a positive 9. Now that we know what b is, okay, you could turn around and plug it in and solve for a. It's not a big deal. But let's just go with our wise choice. And our wise choice is to say, well, x equals 2. All right, so we know x equals 2. We're going to say 13 times 2 minus 34 equals a times 2 minus 4 plus b times 2 minus 2. Of course, we already know what b is, but you don't have to worry about that because guess what? The b part cancels. All right, so 13 by 2 is 26. 26 minus 34 equals, and 2 minus 4 is negative 2, so equals negative 2a. 26 minus 34 is negative 8. Negative 8 equal negative 2a. And then we divide both sides by negative 2. We're going to get a equals a positive 4. So we've got our numerators now for our decomposition, which looks something like this right here that I'm highlighting for you. And I think I've got enough space that I could just say that I put a box here, and I can write in my answer right there. How about that? 4 over x minus 2 plus 9 over x minus 4. And this is my partial fraction decomposition. Again, two distinct linear factors. Okay, so I hope this video was manageable, understandable. If it helped you, be sure to like, be sure to subscribe. Otherwise, good luck with partial fractions, and reach out to me if you need any help.